Money is a bargain that we make with the future. It's not worth anything on its own. The only reason we're prepared to work in exchange for money and give away valuable things in exchange for money is that we know that at some later date we can give that money away in exchange for other people working for us or giving us valuable things. We trust that our lives will be better in the future because we have money in the future. Now, interest is a way of demonstrating how the value of the money itself changes as time goes by. If you have £1,000 now and you save it carefully or you invest it wisely, it might be worth £2,000 in 10 or 20 years' time. So if I offered you £2,000 that you weren't able to touch for 20 years, that wouldn't be worth as much to you as £2,000 that you could have right now, or even in 5 years' time. The concept of present value is a way of putting a number on future money. You can ask yourself how much you'd be prepared to pay in exchange for £1,000 1 year from now. Presumably it's not worth £1,000 to you. You could make more than that just keeping the money in the bank. If you invest £1,000 at 2% interest, you could have 1,020 in a year's time, which is already more than I'm offering you. Would you be prepared to offer £900? Well, probably. I doubt that many people would make enough money in a year unless they found a particularly good investment to turn £900 into £1,000. What about £1,000 in 10 years' time? You wouldn't need as much now to turn it into £1,000 if you had 10 years for it to grow. 30 years? Even more. Well, this is how we can calculate it. We can think of these questions as being a reverse compound interest calculation. If I tell you how much money I have now, you can tell me how much it will be worth in 1 year, or in 10 years, or in 20 years, or 30 years, by multiplying by the appropriate percentage multiplier to the power of the number of years. Look carefully at the calculations here. We're going to assume 2% interest rate. This is referred to as the discount rate when we talk about present value for reasons that don't make very much sense, but you can argue that it's because we're thinking backwards in time. For £1,000 a year from now, we divide by 1.02. We do the opposite of a 2% increase. So what we're saying is, if I have £980.39 right now, I could put it in the bank, wait for it to accrue 2% interest, and by the time it has, I'll have £1,000 in 1 year. The next one tells me that if I have £820 now, I can save it for 10 years at 2% interest, and it would end up being worth £1,000. So £820.35 is the present value of £1,000 in 10 years' time. And for the last one, we should be expecting an even smaller number. You don't need to start with as much money now if you've got 30 years for it to grow. Your £552 will almost double over the course of the 30 years. So if you save £552.07, you'll end up with £1,000 in 30 years' time. If someone offers you a deal which involves £1,000 in 30 years' time, the present value, the current value of that deal to you right now should be no more than £552.07. Because the bank is offering you £1,000 in 30 years' time for the price of £552.07. That's what a 2% interest rate means. In case you're wondering what would happen with different interest rates, at 3% you would make the 1,000 a year from now would end up being worth 971. 10 years' time, 744, and 30 years' time, 412. What this means is, if you are expecting to be able to make 3% a year, you wouldn't need to save as much now to get the same amount in the future. Some investment companies will use a much higher discount rate. They might use 10 or even 15% because they are trying to choose the investments that are most likely to make them a large percentage profit. In this case, surprisingly, £1,000 in 30 years' time is only worth £57 today, because 30 years is long enough for a lot of 10% increases to really add up. A similar question would be, would you pay £5,000 right now in exchange for £1 a day for the rest of your life? Well, if you do some calculations, you can figure out that all those pounds add up to quite a lot of money. It's about £300 or £400 a year. So depending on how many years you expect to live, it could easily add up to more than 5,000. But the problem is, the pound that you get in 60 years' time is worth a lot less than a pound in present value. If you want a pound in 60 years' time, you can save probably 20p in the bank right now, and it'll turn into a pound by the time you get it out of the bank in 60 years' time. Turns out, if you assume just under 2%, which is what you might be able to get in a good savings account currently, if you get £1 a day for 80 years, that's worth approximately £15,000 in present value. So how do we calculate the present value of an investment? Well, in this situation, we're talking about 3 different choices being offered by a pension scheme. The discount rate, which is the interest rate we assume we could get during the years in question, is 5%. In other words, the percentage multiplier for a year of interest will be 1.05. Now, option 1 is an immediate payment. The present value of £8,000 now is £8,000. But when we get to option 2, £12,000, but you don't get it for 10 years, we have to work backwards from 12,000. You think about the 10 years worth of interest that has been paid, and you reverse it. If you apply interest at 5% 10 times, you're multiplying by 1.05 to the power 10. If you want to work backwards, reverse that process, you divide by 1.05 to the power 10. So the net present value of the £12,000 is just over £7,000. If you had £7,367 and you saved it for 10 years at 5% interest, you would make £12,000 for yourself in 10 years' time. Option 3 is a combination, really, of both options 1 and 2. It has one component which is an immediate payment, another one that you have to wait for. So we're starting to see why it might be useful to consider adding present values together. If the first £6,000 payment is worth £6,000 because you get it straight away, and the other one is worth £6,000 divided by 15 years of 5% interest rates, in other words, divided by 1.05 to the power 15, we could calculate both of those values and add them together. The £6,000 is worth £6,000. The second £6,000 payment turns out is only worth £2,886.10. When you put them together, you have an overall total of £8,886.10. To decide which is the best, well, now we have a comparable value. It's no longer a case of, well, this one's more money, but you have to wait longer. Now we've converted them all so that we can think of their present value. In other words, their value to me right now. And it's obvious that option 3 is the best choice because it has the highest present value. You get the same amount of money in some sense in option 2, but because you have to wait 10 years to get a single penny, the actual value of that to you is significantly less. I've made a spreadsheet for calculating present value and net present value. I'm going to talk through what net present value means, and we'll look at a couple of examples. The concept of net present value is a very sensible and straightforward extension from present value. The net present value means the combined total present value of all the various payments that will be taking place. In the example you can see on the screen, there is a £1,000 payment that goes out, that's why it's negative, and then a £2,000 payment comes in, and that one's the positive one. This will be the equivalent of paying £1,000 now in exchange for £2,000 in 40 years' time. Let's say you pay into a retirement fund or some kind of pension plan, and you're guaranteed £2,000, but you have to wait 40 years before you can get the money. Well, you could decide if that's worth doing by looking at the present value of each of those separately, but we could also look at the present value of both of them combined to add together the two present values and get something called the net present value. Then all we need to do is decide if the investment is worthwhile or not. If we have a net present value which is positive, it means that the money we get is more valuable than the money we spend in present value terms. So obviously in this case we spend 1,000, we get 2,000, so it sounds like we're up 1,000, but because the 1,000 that we spend has to be spent now, and the 2,000 that we don't get for 40 years, we need to consider how much we would need to invest at, in this case, 2%, to get the same amount of money, £2,000, in 40 years' time. So if I offered you this deal, pay me £1,000 now and I'll give you £2,000 in 40 years' time, you should probably turn me down. You should say, no thank you, I'm going to invest £905.78 in the bank instead. I'll hang on to the other £95 and buy myself something nice, and at the end of 40 years I'll still have £2,000 just like you've promised me, but I've got it without spending as much money. So the net present value here was negative £94.22. That tells me that the deal is less worthwhile than just investing my money in a bank at 2%. This is a bit of a rough example of what it will look like when you calculate and write this down. The structure is really important here, and it'll become more important when we have more payments. This is a pretty straightforward example. There is a single payment that I make, which we call the outlay. That's how much I have to pay to join the deal. And then there's a single payment here which is called the return. That's the return on investment. That's the money I get back. I keep track of how much I spend and how much I get using negatives and positives. If you're consistent with this, it makes things a lot easier. You can list the outlay and the return all in the same column. You just keep track of money that you have to give away as negative and money that you get back as positive. And the same deal works with both in terms of present value. If you say that I need to pay you £5,000 now and then another £5,000 in 10 years' time to be part of your investment portfolio, well, the £5,000 that I don't need to pay you until 10 years' time, that's worth less, so it costs me less to give you in present value terms. Maybe I could save £4,500 in a bank, and then I'd have more than 5,000 by the time you need to collect the 5,000 from me. So we calculate present value in exactly the same way, whether the money's coming in or going out. In this case, for 0 years, because it happens immediately, the present value of the outlay is still negative 1,000. The present value of the return, which happens 40 years later, is £905.78. So when we add those two things together, we get a negative net present value. The final statement can be a decision about whether or not the investment is worthwhile. I've said that the net present value is negative, less than 0. Therefore, the investment is not worthwhile. We're not getting as much back as we put in. Here's another example. In this case, we're keeping the same discount rate, but the deal has changed slightly. I still pay you 1,000, but you promise to pay me £1,000 in 20 years' time, and then another £1,000 in 40 years' time. So I'm still getting 2,000 back, but half of it is happening a lot sooner. And this, turns out, is enough to balance the scales a bit more in my favour. So the £1,000 that I get in 20 years' time, or that the person choosing to invest gets in 20 years' time, that's worth about £670 in present value terms. The £1,000 that is received in 40 years' time is worth only 450 something pounds. But combined, those two are still higher in total than the £1,000 that needs to be spent in order to join the scheme. Again, this is what it might look like when you write it down. You have an initial outlay of £1,000, you have a return of £1,000 that will be payable in 20 years, which gives you a value of £672.97, and then a return of £1,000 which happens in 40 years. And at the end, you can add up all of the present values to get the overall net present value, taking into account the negatives for the money you spend, the positives for the money you get, and then if, as in this case, the net present value is positive, greater than 0, we can say the investment is worthwhile. We're getting a better deal than the bank would give us with a 2% interest rate. You can see why this system might be quite helpful when you have a big complicated list of investment situations. Perhaps there are various different times along the time frame when you will need to invest money, and there are different times when the company with which you invest pay you. When that's the case, every individual payment can be assigned its present value and everything can be evaluated based on that idea. An investment opportunity requires an initial outlay of £5,000. In return, you're guaranteed a return of £2,500 in 5 years' time, followed by a further 2 installments of £2,500 after 10 years and 15 years respectively. Calculate the net present value of this investment, assuming a discount rate of 4%, and comment on the investment opportunity. We have 4 different payments here. One is money I spend, the outlay, £5,000, and that happens immediately. The other 3 are all £2,500, and that's money I get. One of them after 5 years, one of them after 10 years, and one of them after 15 years. So this is what it would look like if we list it out. The net present value, the total of all the present values, comes out as a positive number. In each case, all we've done is divided the amount of money by 1.04 to the power of the number of years. We're using a discount rate of 4%, so the multiplier is always 1.04, and the power that we use refers to the number of years. We're reversing the effect of 5 years of 4% interest, or 10 years of 4% interest, or 15 years of 4% interest. At the end, we have a positive net present value, which means that we can safely recommend investing with this investment opportunity. It's worth more than putting our £5,000 in the bank, because if we invested £5,000 in the bank, even assuming we got 4% interest, well, we could take out £2,500 in 5 years' time, and maybe another £2,500 in 10 years' time, but at the end of the 15 years, we wouldn't have quite as much as £2,500. Here's another example. In this case, you have to invest at the beginning, and then again slightly later, and in return you get £10,000 in 10 years' time. We're going to assume an 8% discount rate on this one. The discount rate will be given to you in the question. Different industries have different standard discount rates that they apply when they're considering investments. The £3,000 that you pay out, the outlay, has a present value of £3,000. Because it's money you pay out, I record it as negative £3,000. The £2,000 you don't have to pay out for another 2 years. So you can assume that you can hang on to that money and it can work for you and it can earn more money in the meantime. 8% a year is the assumption here. So by the time the £2,000 is demanded from you, you will have been growing some money in an account that you can take that from. In fact, technically, right now, all you need to do is pay £3,000 straight away and save £1,714.68 in a bank account for a couple of years, because in a couple of years' time, that money will have grown to £2,000. I say bank account, you're unlikely to get 8% in a standard bank account, but if you're a merchant bank or some kind of investing company, then potentially you have internal investments that can get you higher returns than a bank might offer you. The £10,000 that we receive, that happens after 10 years, so we need to adjust that back as well. Every single present value that you calculate will either be the same value as the original, if the payment happens immediately, or it will be smaller. If you ever find yourself with a larger present value than the original number, you've probably multiplied by the percentage multiplier instead of dividing. In this case, we get a net present value of negative £82.74. That's less than zero. We've ended up paying more than we get in present value terms. We would say the net present value is negative, therefore this is not a worthwhile investment opportunity. You'd be better off, if you can get a rate of 8% from somewhere, you'd be better off saving your £3,000 at a rate of 8%, saving your £2,000 at a rate of 8%, and by the end of 10 years, you will have more than £10,000 to show for it. That's what a negative net present value tells you. This investment opportunity is not a good deal compared to a regular annual 8% increase would be.